Okay, Advent of Code, day 17. What's going on? We have another grid. Pathfinding. 3 consecutive. Okay. Sure. Seven, 9. Oh, no more than 3. 108. It's wrong. Let's see. Entering. Why is it 106? Three. One, two, three. This is not Dijkstra. God damn it. 4 blocks. Between 4 and 10. Okay. Okay, messy part 1, but very good part 2. So what was going on here? So we're doing pathfinding in this grid. Basically, we want to find the cheapest path from the top left to the bottom right with some conditions. In part 1, the condition is that you can go at most 3 blocks in a given direction. And in part 2, you can go at most 10 blocks, but also you have to go 4 blocks before you can turn again. So this is part 2. So let me just say print solve false, solve true, and then let's talk through how this works. Well, and also make it work. It's another day of being a grid. What was even my bug? Oh yeah, not using Dijkstra. How stupid. Okay. So the general idea for pathfinding is Dijkstra's algorithm, which says, so you have some starting position, which is, well, some distance, right? Any like given place where we are. We have some time that it took to get there. We have some row and column position, and we have the direction that we're traveling in and how many turns we've been going in that direction. And so Dijkstra says you have some places where you could get to. Take the cheapest place and sort of look at what you could do from there. So that's what this does, is it grabs the cheapest thing in the queue, and then we consider walking in all 4 cardinal directions and figure out, you know, a new position, a new direction, and how many times we've been going in that direction. Then we have whether or not this move is valid, which, well, starts with does it take me out of the grid, and then it has the actual conditions for the parts, which we'll talk about later. And then if it is valid, this is like a new destination that we could be at. Right, so it costs some amount to move into that square, which is just the number. And then we have a new cost, new position, new direction, new number of squares in that direction. So you just explore this graph of all of these possible tuples, and once we're done, we've calculated the cheapest way to get to any of these places. We want to get the cheapest way to get to the bottom right, which requires a search because we need to keep track of what direction we're going and how many steps in that direction for the sort of conditions. But we don't care about that. We just want to get to the bottom right. We don't care like how exactly we got there. Like, did we get there by going down or to the right? How many steps down? Doesn't matter. So just take the min over all positions that were actually in the bottom right. And right, so we're keeping track of the cheapest way of getting to each state. And if we've already seen this state, in fact, I can add an assert. Then there's no point sort of re-exploring this because we already explored it from a better place. So that's like the point of Dijkstra, is that the distances come out in increasing order. Okay, so what exactly are the conditions? Equals they actually explicitly say this thing can't turn around? Not super explicit, but probably true. And so we have these two different conditions for part 1 and part 2. Let's see if that works. Certainly does not. Why is this so slow? So that prints out 970 and eventually. Seems odd. Okay, I'm not sure why that's running for so long, but anyway, the point is part 1 and part 2 look similar, except that part 2 has a different condition for the move being valid, which is, so in part 1 you can only go in 3 squares in a single direction, and then you have to turn, and in part 2 you can go 10 squares, but also you can't turn until you've gone 4 squares. That seems odd. Oh, I see. Well, apparently that assert was super slow. It's not really a good reason this should take like 10 seconds. It's not really a great reason this assert should be so slow either. But okay, I mean, I guess I'm doing something silly. Okay, well, anyway, this code could be much faster, but I think this is a relatively clean way of seeing the logic, which is that we are doing this Dijkstra graph search. The graph is defined by where we are, and also what direction we're going in, and also how many squares we've gone in that direction. So it is kind of annoyingly big. Maybe you could get that down. And basically, we just need to try, from each square that we're considering, we need to try the 4 possible moves of, up, right, down, left. there's some somewhat complicated logic from the problem statement for whether or not a move is valid. And then, just try all the possible moves, and at the end, figure out what the cheapest way to get to the bottom right corner was. So that is it for day 17. I might try and clean up my code a bit before I actually post it, because this is kind of embarrassingly slow. But yeah, it's good enough for now. See you tomorrow.